Okay, welcome everybody to Looking Forward to 2021. I am Adam Kabala, the Treasurer of District Pittsburgh. Our first module today is going to be engineering. After that, we'll follow up with beer. I'd like to thank our sponsors, BSG Craft Brewing, Craft Beer Professionals. I'd also like to thank our partners in putting this together today, the Pittsburgh Brewers Guild, and we are the Master Brewers, District Pittsburgh. I'd now like to introduce our moderator for this session, Chris Carr. Chris, take it away.
Good morning, everybody. My name is Chris Carr. I'm head brewer here at Aurochs Brewing Company. As you can see behind me, I'm at work. You'll see everybody else is in their warm homes today, which is really cool. We have three presenters. Our first one is going to be Andy Tavikram, who is he's from Market Garden Breweries in Cleveland, Ohio. Andy is master brewer and co-founder of the Market Gardens, and which include the Market Garden Brewery, which is a brew pub, the Nana Brew Cleveland, which is a brew pub and pilot brewery, and the the Market Garden Craft Brewery, which is your production brewery. Is that right?
Yes.
Okay, awesome. And you've been working on these endeavors since 2010 for the last decade.
Yeah.
That's very cool. I see here that for the last 2 decades prior to this, you've been brewmaster at Dogfish Head in Milton, Delaware, Frederick Brewing Company in Maryland, and Great Lakes Brewing in Cleveland. That's pretty impressive.
Been around a while.
Yeah. I also see here that you are an active Master Brewers member serving as first VP on the executive committee, along with representing District Midwest on the Board of Governors.
Yes, indeed.
That's very cool. So today, this morning, we're going to kick things off with you, Andy Tavikram, and you're going to tell us about external wort boilers and why they're so awesome.
All right. That's my plan. Hopefully the screen will come up. And there we go. So what I wanted to talk about is external wort boilers, because I think there's a lot of people using kind of on a small scale just steam jacketed kettles or direct fired kettles, and that's all well and good, but once you get up to I'd say 20, 25 barrel size, then you start wanting to have a little bit better control over your kettle boil, and so then a few options open up. Traditionally, a lot of people put in an internal calandria, so you've got all this stuff inside your kettle, tubes and heating coils and things like that, and they work. But I think there's a better, more elegant solution, which is the external wort boiler. So I wanted to just talk about that a little bit for those who aren't too familiar. I'll make you hopefully more familiar. So that's the topic. Next slide, please. So that's me, and this is obviously presented to you guys at District Pittsburgh, and I thank you for inviting me. So get right down to it. What is this? What is this external wort boiler? Well, there's a picture of the one at my brewery, on our production brewery. It's conveniently labeled EWB. You can do all kinds of fun things with your iPhone these days. So it's basically just a big shell and tube heat exchanger mounted externally. And so you're basically pulling the wort out of the kettle, running it through a pump. The pump pushes the wort through the bottom of the shell and tube and out the top. And you can see the discharge piping going back to the kettle at 3 different points there. And then you have steam being fed in from the top and condensate coming out the bottom. So that's basically it in a nutshell. But let's talk about some of the things that are involved in maintaining and setting one of these up. So first you need a kettle. You need an insulated tank that'll hold the wort. Should be insulated, obviously. It can be hot. You need the heat exchanger itself. Typically, it's a shell and tube. They can be mounted vertically or horizontally with a slight slope to drain. Sometimes they'll be horizontal with a couple 180-degree turnaround bends, depending on how much room you've got to put the thing in. But I think vertical orientation is nice. You've got the inlet and outlet piping, and you need a pump. That's probably the biggest disadvantage to these compared to internal calandrias is that you do need a pump. Although I'm seeing some internal calandria designs that also involve a pump, so in case they're kind of losing an advantage there. But the pump's got to be properly sized and specified, and we'll talk about that in a second. Then you need some steam, right? So if you don't have steam, that limits your options. You could do what's called kind of a thermal oil system where you have a glycol or oil that's heated up, and instead of steam, you're running that heating media through one of these. That's been done. I haven't seen it, but I've got a friend who has one and really likes it. You need sufficient room to install and maintain these. So we'll talk about that in a bit, but it takes more space than just a standalone kettle. And then finally, you need some simple control devices. You can get very elaborate, but you don't have to be. And we'll talk about that a bit as well. So the piping. This is a picture showing the discharge piping coming out of the top of the work boiler. And I circled the temperature probe there because when we talk about controls, I'm going to kind of focus on that a bit. But that's where we have the temperature probe that is giving us a reading of the discharge temperature of the wort. There's another probe in the kettle, which is showing us the kettle contents. And if you have a traditional internal calandria, or if you just have a steam jacketed kettle, you would just have that probe doing all of your work. In this system, you've got two probes, and really this temperature on the discharge side is kind of what the main control point is for this system. You also have a valve up there at the top. Could you go back for a second? Thanks. The first valve at the top there next to the temperature probe is going into the top of the tank, and the wort is hitting a spreader, wort spreader. It's kind of a conical shaped piece of stainless, and what that does is it takes the wort and throws it out and fans it across the top of the surface of the wort. And that serves to knock down foam, and that's a key thing there because by knocking down the foam that's building up, you prevent boilovers. And one of the things I really like about the EWB is that it's virtually impossible to boil this thing over because of that pumping across that spreader. I've also seen some designs and worked with a design where they didn't have a spreader hat; they had a nozzle coming in at about that same level at the top of the tank, and just the action of the wort shooting across right at the top of the wort level serves to knock down foam as well. And you also have then an option on the lower valves. You have two inlets. The higher of the two is what you would run through to heat up pre-boiling. So you're shooting the hot wort directly into the colder wort. And then finally, the lower valve is actually just dedicated whirlpool inlet. So it's got a specific tangential inlet degree. But I think you probably could combine the two into one if you would want to. But that's the way this one was designed. But yeah, so let's go to the next slide, please. All right, so you need a pump, and it has to be specified for what you're doing. You don't just grab any old pump to use. It should be low shear and low RPM design, open impeller, right? So shear forces are really bad for beer and wort. You want to avoid them. This pump ideally should run below 1,000 RPM and really even below 850 to be most effective. So in this case, this pump does two duties for our system. It's the wort boiling pump, which has one speed, and then it's also the whirlpool pump, which has a higher speed. So we have a frequency controlled device that modulates the pump speed based on our set point. And since it's handling hot wort, which can be a tricky thing because it's very sticky, you either want a double seal or a double seal with a water flush. The water flush is nice. It serves to kind of keep everything moving and not getting all stuck with sugars, shortening your seal life. But interestingly, this pump does not have a water flush. But the pump next to it, which is kind of out of the picture there, which is our knockout pump, that does a water flush. And what else about this pump? It's got to be sized for the right flow rate. So when you're speccing out a wort boiler, external wort boiler, you want to have so many passes of the wort through the system in an hour. In our case, it's six passes of the entire contents of the kettle through the wort boiler in 1 hour. And so running a 35 barrel kettle, which is what we have, You take 35, divide by 6, you get 210, right? By that, by 60, which is the number of minutes in an hour, you get, what is that, 3.5 barrels per minute, which is about 110 gallons. And so that's kind of an important feature. You want to make sure you can actually have a pump that does that. All right. Next slide. Here's a shot of the steam connections. So as I said, you need steam, and this is a fairly typical steam setup you would have, on a jacketed tank or anything else in your brewery. You've got some manual shutoff valves and pressure indication, a strainer. You can see the control valve there. It's the black valve. Basically, it's just a pneumatic valve. It's on-off control. You don't really need modulating control. You can do it fairly simply with an on-off. And then you have the smaller line, the condensate coming back out, which then drops into a condensate receiver and is pumped back to the boiler. I also circled in green there, we have a mag meter on the wort side. And that's just to let us know how many gallons per minute or gallons per hour that the pump is providing, for the wort circulation. So it's such a nice feature. If you have a single speed pump, you probably wouldn't need that. But in our case, our pump's doing double duty. So knowing that flow rate is pretty important. This steam is low pressure steam, by the way, and that's another nice thing about these. This whole system runs on 15 psi steam. So that means you don't need an ASME rated heat exchanger or any kind of fancy extra engineering stamps. And it means most of us that have steam, are going to have at least 15 psi available. So, and that's also important because it keeps your temperature low, right? With 15 psi steam chart, I think that's about 230 degrees, something like that. That's if you're boiling at 212, the delta T there is pretty low. So you're not going to get a lot of scorching. You're not going to get a lot of baked on solids because of that. And also because you're pumping through this system, the wort's constantly moving. So you don't have the issues of, the steam is sitting there just baking the stuff on. It's constantly being scrubbed away. So these things tend not to foul up too much if you take care of them. And I think that's a nice thing as well. All right, next slide. Here's a shot of our control screen in the brew house. It's pretty simplistic. You can see the green valves are open, the red valves are closed, but basically the valve on the bottom, 404 there, is the outlet which goes to the pump, which is M401. And then right above the pump, you can see that it's set for 8,000 gallons an hour, which is our flow rate when we're using the external wort boiler. When we're going to a whirlpool mode, we would then ramp that up to 12,000 gallons an hour, which is much faster. At the top of the EWB, you've got another valve, 401 there, and that is the steam inlet. And just coming out of that, you can see we have the temperature set point for the discharge temperature of the wort boiler. And then in the kettle itself, you've got another temperature set point, which is the temperature of the wort in the kettle. And that's kind of a safety feature. You can set that, which is currently set there at 214 degrees. If you set that and for some reason the kettle gets over that temperature, it would shut off the steam, which would then, and might shut off the pump as well. But in our situation, usually we just set that right there at 214, and it never quite gets there, which is fine because we're really regulating the temperature coming out of the EWB. So it's set at 220. You can put that anywhere you want, but what we found is when you're running at 220, or I'm sorry, yeah, 220, it'll get to that temperature, and then the steam will shut off. It'll run for a while till it cools back down, and then the steam will open back up. So you're kind of doing this two-phase boiling and wort stripping. And so you're saving a lot of energy because you're not just steaming all the time. You're not constantly heating. So you're keeping your thermal impact on your wort relatively low. You're keeping your evaporation rate pretty low. You can get down to 4 to 5 or 6% evaporation. Whereas like in an open kettle with jackets, you're probably looking at more like 10, maybe even 12 or 14% evaporation. So a lot less thermal stress, a lot more energy efficiency by doing it this way. And just a nice simplistic design. All right, next one. Okay, so let's talk about what the advantages are of an external wort boiler. There's quite a few, I think. First of all, you've got flexibility in batch sizes. In a kettle that has jackets or an internal calandria, you're kind of fixed in what kind of volume you can deal with. If you've got traditional steam jackets, you've got to cover that jacket with wort before you really can start boiling. I mean, you could boil with your jackets half exposed, I suppose, but you're really losing a lot of heat transfer surface. But with an EWP, once you've got enough wort in the kettle to just make that loop happen, you can start heating. You can have the thing 15% full and actually, start ramping up to boil. And so we found that we can obviously start the heating up process sooner, so that once we hit kettle full, we are at full boil, or maybe even we're boiling before we get to kettle full. But also, you can do smaller batches or bigger batches. When we're propagating some yeast, we'll brew a 15-barrel batch on our brew house, which is a 35-barrel nominal size. But we've also found that we can knock out 40-barrel batches pretty readily because we have enough room in the kettle. There's just a lot of flexibility. And as I mentioned, boilovers are pretty rare. They're not impossible, right? As I mentioned, if you're going across that spreader on the top, it's knocking down the foam. But if you are pumping in through the lower inlet where you're pumping in the hot wort into the cold side, if you forget to then switch up to the top and run it across that spreader, you could potentially have a boilover. But these things, boilovers are so much more rare, and you're doing closed door boiling. You're not doing it open into the room. So should you have a boilover, really, you're just going to make a mess of your vent stack and all over the roof. But it's just safe. I like that aspect. And compared to an internal calandria, you don't have a bunch of junk inside your kettle. Your kettle can be optimally designed as a whirlpool tank if you want to do it that way, which is how ours is done. And whirlpools are pretty fussy. When they work well, they're great, but you have to design it to be a whirlpool. And so these combination internal calandria and whirlpool designs, I think, never quite achieve what they're going for. But with this design, it doesn't matter what the shape of the kettle is. The external wort boiler doesn't care. It just needs to be fed a stream of wort. And so you can have a properly designed whirlpool with the outlets where they need to be, gentle slope to the one side, and just not a lot of stainless stuff that's getting in the way of proper flow. And here's another advantage. One wort boiler can service two kettles. So we can add another kettle later, kettle whirlpool, and we could tie it into the same external wort boiler if we wanted to. So you're saving some money there. And I think these things are pretty easy to clean and maintain compared to internal calandrias. If you've ever had to hop down inside a kettle because you're trying to inspect your internal calandria or see what's going on, or why that CIP was not effective and where the shadows are and all that, it's not fun. You're down inside this usually hot kettle that's got a sloped floor, which is usually wet because you sprayed cold water in it, try to cool it down, right? And then you're in there and you've got a wrench and you're taking off a hatch, and then you drop the nut and the bolt, which immediately goes right down the drain and into the pump, so then you go, oh shoot, you remember to stuff a rag in the drain, and then you have to take out all the piping down below, and then you come out and then you realize you forgot the rag, which then went into the pump as well. It's a nightmare being inside a kettle to do things. But with an external boiler, it's right out there in the room. It's not hot. You can get to it. And you might need a ladder, but that's about it. Much easier. Also, wort boilers that are external, because you're pumping it across that spreader hat, you have excellent volatile removal. So DMS and things like that are being taken care of really nicely and efficiently. All right, next slide. There's a few more. As I mentioned, you can have less evaporation. So you're saving energy, and you're keeping your TBI values, your thermal stress values on the wort down low, and that's good for your long-term beer stability out in the marketplace. And you really have excellent control over the boiling process. As I mentioned also, you've got the active boiling phase, and then the wort stripping phase, and they're kind of working together just by that steam valve cycling on and off. And here's a big advantage. If something really bad happens, you somehow manage to clog all the tubes, or you hit it with a forklift or whatever, it's pretty easy to replace the thing if you had to, or to maintain it. If you need to go in there and clean out the tubes with a high pressure jets or brushes, you can get to it if it's external. But if it's internal and you're trying to do that inside your kettle, it's a whole different scenario. And especially if you have an internal boiler and say, I don't know, something goes wrong, you have a corrosion problem and you need to just remove the whole thing, that thing's coming out in pieces. It's not just, put a strap around it and hoist it through the roof. It's a much harder job to replace an internal calandria. Also, I think these things the shell and tube design is much more robust in terms of construction compared to a jacketed kettle. Jackets on tanks are pretty fragile, but shell and tube heat exchangers, they're used, in a lot of industries, and they're well built, and you don't have problems with them, imploding because your air vent was clogged, and so you had a collapse due to temperature, differentiation, things like that. Just never seen that happen. Also, if you have a system and you rupture the jacket on your kettle and you find it's difficult to fix, maybe there's some corrosion issues on the jacket material, you can retrofit an external wort boiler in pretty easily with just pump piping and the heat exchanger, right? Otherwise, you might be looking at replacing your whole kettle, and that gets very expensive and a lot of downtime. So those are the big advantages that I see. What are the disadvantages? Okay, so you've got some costs. You got a pump, you have a heat exchanger, piping and controls. Like I said, if you have an internal calandria, so you got all that. So that's kind of the heat exchange version there. And some of these designs do incorporate a pump even on the internal. So really, if you look at those, it's just kind of some piping and controls, or maybe a pump, and it's not much really, especially in the realm of putting in a whole new brew house like we did. That's nothing. It's almost not even noticeable. You do need some space though, right? You've got to be able to put it in. You got to have a place to, put it in the room. And for maintenance, like I said, especially if it's vertical, you need some room above it. If for some reason you would have to go in and clean the tubes out manually, but if you take care of them, you won't have to do that. However, tubes can get plugged up when you're operating these things. The same with an internal system. If you're dumping like a bunch of sugar into your kettle, making a strong beer, you want to leave the thing running with the wort going through it, but turn the steam off for about 5 minutes or even 10 minutes. Make sure everything's dissolved before you turn the steam back on. Otherwise, you can bake those sugars right into the tubes, and then everything's going to get fouled up, and that's a problem. But unlike an internal cooker, which typically is just a tube bundle sitting in the body of the wort, it relies on convection to move the wort through. Those tubes, if they start to get fouled up, the fouling just gets worse and worse because the flow is more limited. And the more limited the flow is, the more excessive the baking on of the solids is, because there's nothing forcing it through. Whereas with an external wort boiler, you've got a fixed surface volume and you've got a pump, so you're getting a better motion of the wort through the tubes, right? But you can get them plugged up. So you need to take care of what you're CIPing these things. And as I mentioned earlier, you need steam or some thermal transfer fluid. So if you're trying to direct fire or electric heat or something like that, I suppose you could do it electrically, but I haven't seen that yet. Yeah, steam is ideal. And as I mentioned, you got another pump in the brew house, right? So I think if you look at what I've just discussed, you've got 2 slides full of advantages and about 2/3 of the slide full of disadvantages. So if you kind of just do the balance there, I see more advantages than disadvantages, which is why I like these things. And that's why I wanted to talk to you guys about them. All right. Thanks. And if there's questions, I'm happy to take them.
Awesome. Thank you, Andy. I did have a question. What is the smallest scale kettle that you can use an external wort boiler on? Does it size up linear as well? If you do
Yeah,
plan on sizing up?
that's a good question. Actually, when I was at Dogfish Head, I found a single tube heat exchanger on eBay. I think it was like $50, so I bought it, and it was about 3 feet long. And I had some engineering students from a local college that wanted to do a project, so we took a 15-gallon beer keg, modified it as a kettle, and we hooked this thing up to it, and it worked. It's really cool. And so, I mean, that's the smallest I've seen, but they scale up, linearly to, I've seen them on 1,000-barrel brew houses, Coors in Virginia, for example.
Very
It's
cool.
been in use for quite a while, so it's tested technology. It's not like bleeding edge or anything.
Cool. Dana Johnson has joined us from Burco, and I see he has a question as well.
Okay.
Yeah. Yeah. So, what level of caustic do you use, Andy, on the cleaning the external wort boiler? Is it higher than the regular CIP in the kettle, or is it about the same?
It's about the same. Typically, kettles, you look at about 3% caustic, maybe 4% if it's really dirty for some reason. But I think the main thing is, so you need the causticity, but you really need to have an oxidative additive.
Yeah.
That's specified from the manufacturer of ours that you need to have that. So we do a stabilized hydrogen peroxide that we add, and that's key. That just flashes all that dirt right off. Without that, you're getting much less effective.
It's going to be kind of a good segue for our next talk, I think.
Yeah, I thought that would be nice.
Thank you.
Well, Andy, thank you for that. We're gonna keep things rolling. Unless Marcus, do you have a question?
Just one really quick one, sorry.
Go ahead.
How distributed is this technology? It sounds perfect. I wrote a whole page full of problems and you answered all of the issues. Why doesn't everybody use this?
I don't know. They've been around for a while, since it's the 70s at least, as far as I know, and they're pretty popular. I know a number of the German manufacturers that sell their systems, and they'll do an either or. You can do the internal or the external. Well, I mean, obviously, for my purposes, I would choose the external over the internal for all the reasons listed. But I think some people just have it in their mind that it's a kettle, everything's got to happen in there, but it doesn't. It really doesn't. Some people don't like the pump. They're like, oh, I'm going to be pumping wort around. It's going to reduce the foam potential and things like that. But I mean, we get great foam on our beer. I think foam comes down to not abusing your wort, and really what you do in fermentation has a lot to do with that too.
Sure. Thanks.
Sure.
Cool. All right, I'm just checking to see if we have any more questions and comments. I didn't see any, so I think we're going to move along. Andy, thank you very much for joining us this morning.
You bet.
Yeah, sounds good.
All right, Dana, I'm going to introduce you. So as the technical director of craft brewing for Burco, you consult with craft breweries, wineries, and distilleries on food safety and sanitation practices. It looks here like you have more than 25 years of experience serving Burco's brew customers, and you're known in the industry as one of the leading voices on sanitation. Dana has been homebrewing since 1989. Dana has authored numerous articles for Zimmergy, The New Brewer, and the Brewery Trade publications, and is frequent speaker at industry events. Dana is a member of the Brewers Association Safety Subcommittee and is the current webinar chair of the Master Brewers Association and technical co-chair for Master Brewers Association Rocky Mountain District. Dana, thank you for being with us this morning. You're going to be teaching us about CIP under pressure and on acid.
Yeah. Well, thanks for having me. So, do you have my presentation? So, if you want to put my presentation on, if you have it, I'll let you drive if you want. Otherwise, I can share my screen. So,
See if Adam has it.
it's time.
maybe some technical difficulties.
Sorry, this is with me. I wasn't aware I was sharing this one. That's my fault. Just give me a second, and we'll be right back.
Otherwise, I can bring mine up too. It doesn't. I don't care either way.
Dana, did you get your beer? The 4 beers from the Pittsburgh Brewers Guild?
Not yet. They tried to get delivered yesterday, I think, and we were not around. Or on Saturday, I was out running around to breweries. So
Okay. There's some really good beers in there.
yeah, there's a package that we got a note from the UPS man that we were not around. So when it tried to get delivered on, I believe that was on Saturday. So, well, would you like me to share my screen?
Yes, I'm gonna go ahead and say go for it.
Okay.
Send it.
Let me try. Okay, and what we got here. Can you see that?
I do not.
Okay. Let me go start shows. Slide from beginning. Okay. All right. Now, yeah, I've got it on mine, but now I don't see you guys, so. Should have practiced. Okay. Well, anyway, I think for mine, it's really kind of just basically a you know a review of what I gave in July. If you saw that I'm going to pare that down a little bit, and just wanted to talk about a little bit about Burco. So Burco's been around since 1953, actually, and I've been with them since the late 70s, and then started calling on the brewing industry in 1995, as Chris said. And when we started, we had basically 2 products. We have the breweries and Acid Right number 2, and yeah, there we go. Now,
Sweet.
okay, and if I could go there and go to slideshow here, yeah, all right. And so we, you know, the industries that we call our protein, produce, further processing, and of course, beverage, brewing, distilling, wineries. Those are all getting much bigger for us these days. And as I said, we started off with Acid Bright breweries. I was trying to get people away from caustic, and that was successful for a long time. But as breweries got bigger and got better PPE, then we went to selling more caustic, and that's been a bigger part of our business lately. And you might have seen the article I wrote on using caustic and hydrogen peroxide, as Andy talked about. And but for the purposes of this talk, can we go to the next slide here? There we go. I wanted to show you some of our customers that we have, including Dogfish Head, Ballast Point, New Belgium, Oscar Blues, Canarchy Group, Denver Beer Company. And at the 2016 GABF, we had about 25% of the gold medal winners using our products. So sanitation is key to making great beer time after time. And so let's go to the next slide. Okay. So the goals of this presentation today, I'm talking about CIP practices, much like Andy was talking about. That's key. And for what he was talking about, you really need to go caustic and hydrogen peroxide there. But with the CO2 shortage these days, we are really pushing the acid under pressure, AUP, and that is been working out really good as long as it's not a biofind tank or an Alco 1072. And I'll talk about some of the pros and cons of that, and then we'll have a quick Q&A afterwards. So next slide. So I know we're all familiar with the pH scale, 0 to 14, 0 being a strong acid and 14 being a strong caustic. And I realize it can go over that, but 7 being neutral with neither being acid or alkaline. But what a lot of people don't consider is the organisms when you're cleaning. And why you want to stay in these ranges. So when I talk about strong acid cleaning, that's a pH of 0 to 2. You always want to stay below pH 2 if you're trying to clean with acid, and especially acid and detergent only, because that's key. Because not only are you doing the work there at that level, but that's going to kill yeast even. And phosphoric acid. Washing of yeast, they tell you not to go below pH 2.2 because you're going to start stressing the yeast. So that's key if you're doing acid under pressure of bright tanks and so forth. So I'm not going to really go into the rest of them, but you can go to the next slide. All right, there's the solubility of amino acid. Unfortunately, beer is about pH 4.5, and that's where you have very low solubility of amino acids. So those are the building blocks of protein. And when you talk about beer stone, that's a tenacious soil. What they mean by tenacious is it's binding. It likes to grab onto the metal, and that's where you get that kind of the sandpaper like appearance to the metal. Feels very rough. Those protein bonds in the beer stone make it very difficult to remove. So I kind of keep this graph in mind, and that's because the further we get away from this pH 4.5 in either direction, you're going to have better solubility, and I'll talk about the reasons for that here in a sec. Go ahead and go to the next slide. Here's some of the soils that we're talking about, and of course, a lot of protein and beer stone, hop oils, and that. And in the beginning of the process, and same with heat exchanger and what Andy was talking about, and the external wort boiler. When we get into protein in the aging tanks, as I mentioned, that's going to be more of the beer stone. And the other thing that I need to probably add to this slide moving forward for future presentations is the biofine, the silicon dioxide, or Nalco 1072 from Country Malt. If you're using that, you don't want to use acid to remove those. It sets the silicon dioxide to the metal. It makes it really hard to get that off. So you want to use caustic or alkaline to clean those. But go ahead and go to the next slide. And when thinking back to that diagram on the protein, the amino acids, hydrolysis is what we're kind of talking about. That when we get to those strong pHs, hydrolysis means breaking down with water, and so that's different from non-caustic cleaners use the dissolution. So that's like your PBW and some of breweries, Cellar Master, or those kind of things. There, you're just trying to kind of get them off of the metal surface with displacement and dispersion. And the emulsification is usually done with surfactants and solvents. The peptizing is breaking down of the soil. Then the chelation really comes into play with on the alkaline side, but is important with acids too. We have a lot of chelation in our additive package for cleaning with acid and detergent only. So next slide. All right. So which acids are best for cleaning with acid and detergent only? Well, we've started selling more hydrochloric to clean up hot liquor tanks because it's a really good one for rust, but it's not good for the metal. Generally speaking, to clean with it on a regular basis. That's more for remedial. Most of the time, you're going to have phosphoric and nitric, or nitric phosphoric. The phosphoric nitric means that it's got a higher level of phosphoric and a lower level of nitric. Phosphoric obviously means that you're going to have a higher level of nitric and a lower level of phosphoric. This is kind of where in areas where they're trying to watch the phosphate load going down the drain. And then the surfactant blend will be very proprietary, typically, like our X-Puma, if you're familiar with that one. But that's just in there to kind of help. The acids don't clean very well. They're not good wetters, and they're good at dissolving calcium and magnesium and things like that, and rust, as I said. But they don't wet out. They don't disperse. Next slide. So the key on cleaning with acid detergent only is you want to keep your pH, as I said, between 1 and 1.5 is optimum, definitely below 2. We actually sell these short-range pH test papers that go from 0 to 2.5, and there's a they're kind of red until you get to about pH 1.6, and then it kind of goes orange, and then once you get over 2, as you can see on this right side, when you get up to about pH 2.5, it's yellow. So if you're not down in this strong 1 to 1.5 range, you need to add some more acid. And if it won't go to that level, that means that there's a buffer that you've cleaned, usually from in kegs or something like that, that is buffering it up, and it's time to discard the solution. Next slide. So the secondary fermentation vessels, bright tanks and things like that. What you're going to see on these slides coming up is a 3% S-splide nitric phosphoric blend and just a 0.25%, 2,500 parts per million of the detergent. It was our X-Puma, and then a rinse cycle, and then the PAA. So go ahead and go to the next slide. So there you have your typical, not a real heavy Kreuzring like a primary fermenter, but this was an aging tank. So it's got beer that's, been sloshed up there and is kind of dried on it. So not too hard to clean. And usually the beer's not in there very long. So that's what it looked like beforehand. And then go to the next slide. And that's what it looked like afterwards. And this was important that they wanted to do the acid and detergent only cleaning on this, because as you know, if you're cleaning with caustic, what do you have to do? You got to get all of the CO2 out of that tank. So you don't you have to get all of the caustic out of that tank so the CO2 doesn't suck it in and implode the tank. So that did a really good job of cleaning, but more importantly too, it was quicker, less energy, and the ATP testing on it came back really, really good. So low RLU numbers on that. And so this is if you get into, that's a 2,500 hectoliter tank, I believe. So big tanks. When you get into that, that's a huge CO2 saver as well these days. And that's become very important. Okay, next slide. Tank cleaning is another area where this has turned out to be, it worked better than I thought it would, especially when I came up with this idea of cleaning kegs under pressure with, actually in this case, at Avery, they had an air compressor, but you can actually clean kegs if you don't have an air compressor and do it under, CO2 pressure with acid and detergent only. And when I tried this at Avery, I said, I don't know if it's going to work, but let's give it a shot. And lo and behold, it worked better and recycled far better than what they were doing, and with using a chlorinated caustic. in a homemade machine. They went to a Comac machine in 2007. And go ahead and go to the next slide. We'll kind of show what that looked like. There's a 60-gallon reservoir. We were charging that with a gallon of nitric phosphoric, or ultraniter, and then just a little glug, a couple ounces of the X-Puma. You don't want to go. People get confused on the detergent additive. They think it's 2 ounces per gallon of water. It's not. It's only 2 milliliters per gallon of water. So it takes very little of the acid, detergent additive. When you're doing that, you can actually run into foaming and rinsing problems if you overdo the acid, detergent additive. So go ahead and go to the next slide. Key on cleaning kegs in this manner is you got to do a good purge up front, and you want to do a warm water or hot water rinse. The key, I think, that made this thing work was I had either a choice of going with stone cold boulder water in the winter, which could get down probably in the 50s, or hot, basically hot liquor tank rinse up front. I chose the latter, so the hot liquor tank rinse up front, I think, was key to making this thing work. Go ahead and go to the next slide. So that's what the 2T machine looks like. It does the air compressor purge on the left side, then the rinse, obviously, as you saw there, and then clean, and then triple rinsed, and then it goes to the right side where it gets a steam sanitization, which I think was key as well. Those are microstar kegs, obviously, as you can see. And when I gave a talk on this in 2009, they'd been running it for over a year, probably a year and a half. And I said, how many kegs do you get back? Normally, he said, what do you mean? I said, well, everybody has bad kegs. He goes, well, we had one that came back, but we think it was a bad tap line. So keep in mind, when they started, they were doing about 300 kegs a week. And by the time they retired that machine, they were doing 300 a day. So that was pretty impressive. Go ahead and go to the next slide. All right. So this is what I went up there and see how things were going. These kegs were all ready to go. This was back when draft was really coming in, and I was very impressed with how much beer they were. It not only did it do a great job, it sped things up a lot. So to do 300 kegs in a day, they were, and it cut their cost by 90%. So pretty happy with that as well. Next slide. So, yep, bright tanks are perfect. These are kind of their smaller ones, but even if you have a small brew pub or something like that, if you're struggling with CO2 supply, or if you just want to be better for the environment, and this is a really good way to clean bright tanks, especially if the beer's not in there very long, and you don't have a lot of mixed organisms in there, and you're just doing straight beer. I highly recommend it. And if you probably talk to Marcus, I think he uses this approach as well. If you're doing a mixed culture, you probably want to go ahead and, if you've got sour or red in there, and then you're going to a regular beer, probably want to break it down, get all the CO2 out of there, do a good caustic clean. And I still recommend our acid first, followed by non-caustic procedure for these, every so often, at least twice a year, just to keep the metal in good shape and do a deep clean on it. Go ahead and go to the next slide. And there we go. Okay. So, yeah. Beer stone tends to be a big issue for you, then that's definitely a way to go. Again, though, I want to stress to you, if you're using Biofine Clear, especially in a bright tank situation, if you're using Biofine or Nalco 1072, do that in the fermenter. and because you're going to clean those with caustic anyway, but shouldn't be too much of that left. By the time you get to your serving tank or bright tank, that should all be out of there. And but the advantage of this method too is when brewers in Colorado started going to this acid and detergent only, the subsequent beer going through those tanks had a lot lower DO level, the packaged product. So, instead of being around 40 ppm or ppb rather, they were around 10. So that was another benefit of that. Go ahead and go to the next slide. All right. So here's some of the advantages again. Ideal for bright tank cleaning. They're usually not all that dirty, especially if the beer's in there just overnight. And as I said, don't use acid if you've got biofine in there. It will set it. And then it plates it to the metal, and then you've got to use a lot of caustic to get that out of there. So it has had less O2 pickup. Go ahead and go to the next slide. All right, tap line cleaning, and filler bowl cleaning. I think that acid, quarterly, is what the Brewers Association draft beer quality (DBQ) draft beer quality manual says quarterly. I am of the approach was if that's working for you, that's fine, but I think that acid cleaning of tap lines and in sometimes filler bowls is not done enough. And I'm a big fan of running more acid through there than quarterly. But that's because we sell it. But yeah, it's based on need too. If you need to do it more often, then by golly, go ahead and do that. But be careful with acids on brass and other soft metals. You don't want to pack brass faucets with, acid, that kind of thing. So go ahead and go to the next slide. To getting back to the detergent additive, you get better soil wetting and penetration compared to using acid alone, and getting into that protein. A big reason that we were able to get 300 kegs out of that 60-gallon reservoir in a day was that detergent additive really does help kind of displace the soil and then keep it in solution, or it floats out. One of the things they do in rendering to split that is actually drop the pH. So a lot of that soil just comes to the top, and then it can kind of be just removed by a rag or something. And you get better rinsing with a detergent additive, and that's where the chelation comes in. You've got to have a chelator in there, so when you start rinsing, if you have hard water, then you don't want that plating out on the metal. So next slide. All right, nitric is a good passivating, but it's really aggressive on organic soils too. So again, when I talk about the protein, those are carbon containing, so that's why you want to use nitric. And the phosphoric is, if you can use it in your area where they're allowed. The phosphoric is a good buffer. It's H3PO4, so there's 3 acid sites instead of just one. Like nitric is HNO3, and it helps kind of tone down the aggressiveness of the nitric. So these recycle easily. You want to get to a pH typically of say 6 to 10, whatever your wastewater people want to see. They're easily neutralized, but in pre-treatment, they can go down the drain. Next slide. They recycle well. Acid and detergent does save CO2. It's unaffected by CO2 in the keg. That was one of the things that I noticed. The pH didn't budge, especially in keg cleaning. You do need to add a little bit more acid probably during the day if your pH rises. But sometimes, especially in certain beers, the acid may not be as effective on maybe say a wheat beer or something like that. That's really sticky. If that's the case, you do probably want to go with the caustic hydrogen peroxide. And make sure your detergent blend works. The way ours works is you just put the acid in the water first, and it remains water white. Just add that small amount, the 2 mils per gallon cleaning solution, and it turns it very turbid. That's how you know it's in there. But you can also drop it on, take a drop of it, and surface test, easy surface test to do. Take a drop and put it on like a plate or a petri dish or something. And if it beads up, if you've got a real high angle on there, then you want to see it just kind of spread out. So, yep. And so that's about it. I think if I can take it for questions now, Chris, if you want.
Chris?
Yeah, Marcus.
Oh, sorry, I had my microphone muted. I did see that there was a question about when people add a ton of fruit to their bread tanks.
Fruit, yeah. Sometimes the pectins can be an issue. There again, the temperature and can come into play. One of the things I didn't talk too much about is when you're using a nitric blend, you want to keep it below 140, but the optimum temperature in cleaning with acid detergent is 120 to 140 degrees Fahrenheit. So that's probably like 40 to 60 degrees C if you operate under Celsius. But that's the a big one that will help with that. But again, the nitric's pretty good on pectins. But the detergent additive will also help wet that out as well. So that's a really good question. Anything else?
I think Dana, just in terms of time, we might need to move it on, unfortunately.
Okay. Alrighty, that's fine. So you can always contact me at Burco.
And if anybody locally in Pittsburgh has any questions about the Burco products, I've been using them for a long time, and I'm more than happy to have you come down and see what I'm doing down there.
Yeah.
But it's pretty much clearly that the temperature's really interesting at the 140F, the concentrations, the dealing with the pressure is a little bit challenging, but it's all, you just save so much money and it works every time. It's unbelievable.
Yeah.
Cool. All right,
Okay.
so thanks, guys. Let's move on to the
Thanks,
next
Dana.
one. Chris, yep.
Thank you.
All right, so our third presenter, Jaime Jurado, could not be with us today. He is, I think he's in an airplane right now. He has some travel conflictions. Yep. What was that?
He had a rescheduled flight, so unfortunately he's in the air instead of on the ground right now. Hopefully landing very soon.
Okay, well, luckily we were able to get his a video of his presentation that we will be able to share. A little bit about Jaime is he works for Ennoble Beverages, who make flavored malt beverages, such as the TGI Fridays Long Island iced teas, or the blackberry iced tea. There's Frank's Red Hot Bloody Mary, which I have had. It's pretty spicy. It's pretty good. Jaime is going to talk to us about pasteurization in this video.
Hello, I'm Jaime Jurado. I'm honored to be part of this virtual conference organized by MBAA District Pittsburgh in coordination with the local Brewers Guild. Today, I've got about 15 to 16 minutes to talk to you, so I'll get right into it. I'm recording from Seattle. The reason I'm not doing this live is I'm actually flying during my scheduled time. So the organizers have kindly allowed me to do this via video. Okay, let me find my, there we are. And we'll share that. Okay, so my talk today is on pasteurization and preventing re-fermentation in the package and assuring stability. In the short time that I have, I will be describing all the options that I know of on how to achieve stable beer. Okay, now, 15 years ago, we didn't really know about all the crazy things that breweries have been making these days. Barrel-aged beers, wild brews, hard seltzers, kombucha, ciders, beer wine hybrids, coffee-based beers, infused drinks, flavored malt beverages. My own employer, that's the space we work in, flavored malt beverages. We make products that there's not a lot of competitors for them. We make malt-based Bloody Marys, for example, where we need certain technologies that are not typical in breweries that we have to invest in. And we make, Moscow Mule, Long Island iced tea, and we continue to find our niches in the fringes where there's not a lot of competitors. We're not making hard seltzers, for example. Breweries are increasingly making no alcohol beers, natural soft drinks. So new product development has driven so many breweries to do new things. And part of what the reason I'm giving the talk is just to kind of remind people that there are responsibilities that we have when we make products to our customers. And we'll talk about stabilizing microbiologically. All right, so in my overview, hopefully it'll be less than 20 minutes. I'm covering microbiology, cold options for sanitizing, sterilizing rather, a product, batch pasteurization, flash pasteurization, and finally tunnel pasteurization. And we're going to go through a walkthrough of the calculations. I'm not doing comparisons in terms of flavors or performance or anything like that today. I've done that before, but we really don't have the time to look at these too much. And it's not a survey of solution providers. Okay, so we're looking at this mostly from the lens of an engineer. Now, the unwelcome microorganisms we deal with are, there's a whole bunch of things, and some of them are thermophilic, for example. It depends on what we're doing, what we have to worry about, but, the first thing you got to think about is how do you actually measure these things? We know the fastest way of measuring many things is through PCR. And over the past years, PCR has become more and more robust and broad, offering more identification of species on a very rapid basis. But then again, there's traditional microbiology in which we're using anaerobic testing, aerobic testing, and separately yeast and mold testing if one wants. Okay, start off with chemical preservatives. You don't have to use heat to make a beverage, alcoholic beverage, that's stable. There's a lot of things that work to stabilize beverages, bisulfites and metabisulfites. And here's a listing. There's a product down there called Velcorin, which is applied right after filling and before seaming or crowning. And it's actually more powerful than heat pasteurization. It is a form of mustard gas, very dangerous, but it's been used and developed around the world. And there's many German beverages that are using it. I know ciders in the States made with it, but you just dose it in. And there's a new product called Chiber that comes from a button mushroom extract. Again, it's very powerful. And from the makers of Velcorin, there's a product called Nigardo, which has not yet been approved of for alcoholic beverages. It will get at some point. And that's also a mushroom-based extract. And as we know from Cokes and Pepsis and sodas, potassium sorbate and sodium benzoate are often used at 300 parts per million to give you a stabilization. Well, the world of cold sterilization continues to evolve. There's cross-filter options. For example, Nort have several units at craft breweries. The one at Porterhouse in Dublin has been working for about 3 years now, using their ceramic cross-flow for filtration. And I should, at best, it's barely near sterile filtration. Paul have a cartridge-based system here that is they claim to replace pasteurizers. They call it the pair set, pasteurizer replacement in beer. And all these kinds of membrane filters always have pre-filters. Then they go into the real filters. So in this picture that I show you here, all those things to the right are pre-filters to just make it clearer and clearer and clearer, so that when we get our near sterile product at 0.22 micron filtrate, we have long life and good flux. Flux liters per meter squared per hour does decrease over time. You can regenerate, clean, but eventually you'll get less and less throughput. You get irreversible fouling, concentration polarization, which you can't clean. So then you have to periodically change the filter elements out. Membranes like these require CIP after every 45 hours of continuous operation. If you're not operating continuously, you just CIP them after you're done. Beer has natural components within it that serve to challenge unwanted microorganisms, hops, alcohol, reduced pH due to carbon dioxide, but big differences in microstability at pH of 3.5 compared to, for example, beer pH 4.2. So the lower the pH you get, the more robust and bulletproof your beverage is going to be. Thermal systems work by inactivating the cells through heat. Membrane filtration works by removing cells. Okay, so pasteurization, we're now moving to our pasteurization section. Applying heat to preserve and extend product shelf life has been demonstrated at least since 1117 AD in China. Louis Pasteur, of course, did his work with beer, wine, and milk. And in 1864, he did his development work. Now, the first stage of pasteurization one can look at is a batch pasteurizer. This is one made in Milwaukee by Pro Engineering, and in which you load in your cases of product, close it down, and go through a recirculating shower at different temperatures, and you actually expose it to the heat regime you want. And we'll talk about that in a moment. But in this case, after you pasteurize it, you can remove the cases and put in 2 more. So it's a definite batch-wise step. The same manufacturer, which we'll close up with, makes tunnel pasteurizers that are continuous flow through pasteurizers. The calculations on pasteurization, just so everybody's clear on how simple this is. I'll close my presentation with a site from the 50s of the first quantification of pasteurization for beer. But if a beer is pasteurized at 60 degrees, the number of pasteurization units is equal to the length of time in minutes of heat treatment during pasteurization. So we have this thing called a pasteurization unit, a PU. That's something that we can calculate in terms of exposure. If beer is pasteurized at a temperature of above 60 degrees, 60 degrees is 140 degrees Fahrenheit, for a time of T minutes, then the pasteurization effect increases by a factor. And here's the factor, here's the equation. 1.393 raised to the power of T degrees centigrade minus 60, the reference. So the pasteurization per minute is given by what you see on the right. So let me put a little bit of meat on the bones on that. Again, the pasteurization at any given temperature is the time that it's held at that temperature times that factor, where it's the whole temperature minus 60 degrees at the reference. So example, we'll give you an example now. If we pasteurize beer for 10 minutes at 62 degrees centigrade, the pasteurization would be this equation, 10 times 1.393 times 62 minus 60 equals 19.4 PUs. Now that actually is a little bit high for pasteurization. One of my projects I did in my past life was come up with global pasteurization parameters. And we had to have a target of 15 pasteurization units, but we would not allow more than 1 out of 100,000 packages to be less than that. So we use something called Monte Carlo modeling, a software program called Crystal Ball, which operated on Excel. And we actually had to set the global pasteurizers for that organization to 20 pasteurization units so that we would have less than 1 out of 100,000, at least mathematically, would not be under pasteurized. And the reason one does that is because sometimes you have a long shelf life, i.e. 9 months, a year, and you can't take a risk. So back to Basket in 58, put up this interesting little tool. At 170 degrees pasteurization, one calculates that per minute, you get about 18 PUs per minute of exposed. Now, pasteurization actually starts at 140 degrees. So if you think about pasteurization, when you have a package being heated up to be held and then chilled down, that once you're at 140, it's like you're hitting the bacteria with little plastic straws. And then it gets a little warmer, and then we're moving to, sticks, and then ball peen hammers, and then bigger hammers, and finally sledgehammers. And then we chill it down. And once it gets down to 140 again, we're no longer pasteurizing. Now, what our objective is to avoid shooting ourselves in the foot. I won't share sites here. We don't have time, but even this week, Guinness with its new 0% alcohol stout had to have a major recall. All of it that's been produced, which it only launched 2 weeks ago, is being recalled because it has micro counts. So we have a couple of factors in pasteurizing. I've showed the batch pasteurizer. That's kind of like a starter pasteurizer, something for maybe limited editions, or if you're really small, but at some point you'll probably have to upgrade and change to something that's more steady state. The factors to consider are the footprint to install a pasteurizing solution, the flexibility to change the target pasteurization for different beverages, the energy and water consumption parameters, and the care and feeding preventative maintenance units. Let me talk for a moment about a flash pasteurizer. This is one that's made in California. There's several options made by the company, in which you have a small footprint, and basically we heat up the liquid to be pasteurized to a certain temperature. We're going to hold it for a certain amount of time, i.e. a minute or 2 minutes, and then we're going to chill it down. And today's designs have a heat reclaim. So the energy consumed in heating the product is then later on, it's captured and reused. And the incoming water, which might be ambient, is actually preheated by heat exchange with the very hot liquid, the beer. So this is one of the units that's made. And again, it depends on the pump, but you pump through it. You can have a VFD or you can have a steady state. And you typically have an inlet feed tank and an inlet outlet buffer tank. So we have steady flow. These things really like steady flow. They don't like discontinuous flow. And, you see them often in keg lines because you can go right from the outlet of the pasteurizer to the keg line. You see it less with packaging lines, with bottles and cans, because then, I shouldn't say you see it less. It's generally you need to size your flash pasteurizer to keep up with the filler bowl. Otherwise, you have to go through an intermediary bright beer tank once hopefully you've made it sterile as possible. So that allows you to fill up a tank and at a slower rate than you're actually pulling from it. Now, this is another, I think the last one made in the Midwest. This was Barry Weimiller, no longer making flash pasteurizers. But the thing about a flash pasteurizer, and so this one off to the last two pictures to the right show that one. To do flash pasteurizing right, you have to remember that once the product leaves a flash pasteurizer, it's been pasteurized, but you can still get reinfected later on at seaming, at crowning, at filling, at later stages. So the belt and braces approach is to put in a sterile air filler, a filter system. So you have positive air pressure over the filler and the seamer or the crowner. My first experience of putting on one of these things was at the Trumer Brauerei in Berkeley, California, where we had a nice Mecafil 2 filler from Crohn's. It cost us $1 million. And Crohn's introduced us to a company in France that also had production facilities in Quebec, where they measured up and they made a really nice enclosure that looks like it's part of the filler. And all that does is it has a HEPA filter, and you can feel that every place that there is a crack or a space, positive air, sterile air coming out. So the idea is to simply overwhelm anything and not allow it to get into the filling space. And some of these units have UV treatment of the air too. We didn't. But it had nice differential pressure gauges, so you knew when to change the filters when they got too high. So my products, because they're made with juices like our tomato juice, we have other things we worry about. Even in greenhouse tomatoes, they do touch the earth. And there's certain things that can be on the ground, things like Clostridium, Zymomonas, and even worse things. The bacillus responsible for botulism. And we see a lot of little linear can fillers that to me are a microbiological worry. While they might do a fine job, the fact is the first can that's presented is going to be the first can seamed. And although we have lids loosely on the other cans, we still have an area for microbiological contamination. So a tunnel pasteurizer is a really nice way to sleep better, in the sense that once the bottle is filled or the can is filled, it goes through this tunnel, which is just a long shower. These both were made by Pro Engineering in Milwaukee. The one on the right is a small one that I've seen before, for example, in a cidery. And all these things do is they grow, and you feed them, and it's a steady feed, and they're sized to match your filler bowl. One that I put in at a brewery in Pennsylvania was here is it open, just evaluating the sprays, was doing 100 packages a minute, and it was 38 feet long, 5 feet wide, kind of cute, but I needed the footprint. If I didn't have the footprint, the options we would have been put in a flash pasteurizer, which takes up about 40% of the footprint. But then I would need the sterile filling head, in this case over our Moravec, our Czech-made can bottle filler and crowner. The brewery also now has a can line, which I believe they route also alternatively through the pasteurizer. And on the left, you see the sprays. These are non-fouling sprays so the shower uniformly hits the bottles. With a tunnel pasteurizer, we have the ability to put lagers. The left is the lager, the Red Post lager made by Halfman's. The right one is an Eklund Heartland one, where we have a probe that actually goes in the package. The one on the right doesn't show the can, but it would have one of our 19.2 ounce cans, or 16 ounce cans, or 12 ounce cans. And that way we can track the actual temperature of the core of the can. And modern pasteurizers have automatic recordings on also, so you can see what's going on. There's a number of units of little logging computers, so you can see how much exposure you've got, and you can dial in your pasteurizer. Now, again, this is my product, our extra spicy. The good manufacturing process is attentive cleaning, sanitation of all processes and unit operations in the BBT and in packaging prior to tunnel pasteurizing or after flash pasteurization are mission critical to any belt and braces approach. One of the questions that I get asked often is, how do these things cost? And it's counterintuitive. A small tunnel pasteurizer might cost you $160,000 that's capable of handling 100 packages per minute. Now you're going to have to treat the water, do some certain things with it on the care and feeding. A flash pasteurizer was going to cost you more, and it's going to be a smaller footprint. And then you have to worry once it leaves the flash pasteurizer. What do you have to do to make sure that you're not going to pick up microbial issues? For example, at the new Alamo Brewery in San Antonio, they're putting in a brand new Italian-made can line, and they're putting in the sterile air filter, which I believe is not only a HEPA filter, but has the UV lights on it. And they're putting in a flash pasteurizer. So, and their flash pasteurizer has been sized so that it is feeds directly to the filler, not to, although it has a small buffer tank, of course, between the flash pasteurizer and the filler. That way, they keep the flash pasteurizer running steadily. So that is my nickel tour of the options we have to have sterile beer. Nobody wants beers coming back or beverages coming back because the cans are exploding. We've all seen that. We know that even great breweries like Goose Island, after they were acquired by Anheuser-Busch InBev, had an issue with the recall on one of the batches of their barrel-aged beers, for example. There's many, many examples of how this goes wrong. We've all seen it. But by having the right treatment, and chemical treatment is an alternative you have. I don't like it myself, but it's legitimate. And sterile filtration is great unless you're doing a cloudy beer. Then you have another issue to deal with. How do you manage to get sterile filtration and have a cloudy beer on purpose, like a New England IPA? And there's some controversy of how much stripping does filtration do. Finally, pasteurization, either flash or tunnel, will allow you to sleep better. So I hope it was an interesting talk. Thank you so much.
Chris, if you want to move on to the beer tasting portion. So I believe we were going to discuss your beer, correct?
Yeah. We brewed the hazy IPA. I have a can right here.
So I'm going to bring back, not to interrupt you, I'm going to bring back the rest of our panelists as well, who were lucky enough to taste the beer. So hopefully Andy has some positive things to say for you as well. And I'll add Dana, who I don't think has gotten the beers quite yet. But
not yet.
I'm sure he would have. I'm sure he'll also have some interesting questions about it as well. And with
yeah,
that,
let me
I'm
actually go grab one.
Sure. And actually, while he does that, I'm going to sign off so that I can get us ready for our next module coming up, which is beer. So that's going to feature Liz Pratt, Lindsay Barr, and Will Kemper. So thanks again to our panelists. Thanks again to our sponsors. And I will see the rest of you in the beer module.
All right, guys, I'm back. I'm actually going to pour one of these into our awesome plastic cups, thanks to COVID. Andy, I'm curious what you thought of the beer. We were able to send you out 4 beers, all from Pittsburgh.
Yep.
All of us are on the Pittsburgh Brewers Guild, and most of us are master brewers as well. The beer that we brewed, that we sent you, was our New England IPA, our hazy IPA, which just took home a gold medal at GABF this year. We were very excited for that. We all worked really hard for it, so it's very cool.
Yeah, that was delicious. I mean, I thought all 4 beers were really well done, but that was a really nice example of the hazy IPA style.
Thank you.
Just smooth, no egregious hop burn or anything like that. Obviously, appropriately hazy.
Yeah.
Awesome. And
Congratulations, by the way. That's I was a judge at the Great American Beer Festival this year, so maybe I had a chance to try it.
I hope so. Well, if not, you definitely will. As soon as that package comes in a couple days.
Actually, don't.
Andy, you cut out for a sec. What was that?
Yeah, my Wi-Fi is totally screwed up right now. It seems to be the theme of the day. But yeah, good beer. I mean, great beer. So congratulations. And yeah, I chugged it right on down. I mean, it didn't have any issues.
Awesome. Yeah, I mean it's a 7% beer, so it'll creep up on you after a few. Yeah, we just brewed it with Mosaic and Citra. We use alternative grains. So every time we brew a batch of beer, it's we're doing some more research and development just because there's not a whole lot out there from just the last 10,000 years of humans being able to brew beer to the last 40 years of just the Americans' influence on craft beer and kind of where things are now. So we're trying to add a small piece of the puzzle just to include more people into craft beer. So we're very happy to be a part of everything, to be a part of the industry that's extremely inclusive.
Yep. Nice job.
Thank you.
What category was that you won in?
So it was the gluten-free category.
Gluten-free. Okay, yeah. So there was on that one there was just a gold and a silver on that one.
Yep.
Yeah, there was no bronze in that one.
Yeah, we were trying to figure that one out, but I mean, there are some nice gluten-free beers that represent some traditional styles. There's maybe a dozen dedicated gluten-free breweries in the country, and some of them are fortunate enough to be able to go out and taste these barley-based styles and try and create it as a gluten-free offering for those who can't have it. So that's what we do here. The two founders are gluten-free. One has been gluten-free most of his life. The other one recently, when I say recently, over the last 10 years, discovered that he was also celiac. So it was kind of a love and loss because he was already drinking some fantastic beers. And that was the birth of Aurochs.
I'd like to thank our host. Thank you, Chris, for moderating.
Thank you, guys.
Thanks to BSG again for being our major sponsor. Thanks for partnering with us, both the Pittsburgh Brewers Guild and Craft Beer Professionals, the most fascinating Facebook kind of brewers group available that I've seen. And we'll just everybody leave the studio and we'll shut this down and we're all done. Okay. Sorry to end on such.
Have a good day.
So
Thanks, everybody.
onwards and
Take
upwards.
care.
All right. Thanks, gentlemen. Thanks for your time. Bye.